Just as we can multiply two radical expressions together, we can also divide them, and we'll be using a very similar idea. Anytime you have two radical expressions with the same index, and you're taking the same type of root, if you're dividing those two radical expressions, then in order to simplify it, you could combine the two radicands and take the quotient, a over b, and then take whatever root it is that you are dealing with. So let's do a couple of examples. Let's say we want to simplify the square root of 50 x to the 6th divided by the square root of 2x to the 4th. So the first thing that we're going to do is just combine this into one big square root. And we can do that again because we're taking a square root in the numerator and the denominator. The index or the indices on both of these expressions is the same. So this will become the square root of 50x to the 6th divided by 2x to the 4th. The next thing we need to do is to simplify each type of component in that radicand. So we're going to simplify 50 over 2, that's just 25. And then we can simplify x to the 6th divided by x to the 4th. Since we have the same base of x, all we need to do is subtract those two exponents. And so x to the 6th divided by x to the 4th is x squared. And then in order to further simplify this and get our final answer, we need to take the square root of 25, that's 5, and we need to take the square root of x squared, and that's just x. So it looks like we've got this expression completely simplified. But before we finish, we need to think about what we talked about the other day, that when you're simplifying radical expressions, there will be times when you need to use an absolute value bar in your final result. And we're going to need to do that here because in our final result we got an x to the first power, which means that if we had a negative value for x, that would end up being negative out here, and of course when you take the square root of something that can't be negative. So we can't have any negative values for x. We're going to need to have the absolute value of x here. So our final answer is actually 5 times the absolute value of x. Let's do one more example. Another way that you can go about simplifying radical expressions when you're dividing two of them is that you can first rationalize the denominator. We've done a little bit of this this year already, so this is just an extension of the same idea. To rationalize a denominator means to get rid of any radical expression that's in the denominator. And when you do that, you're always going to be multiplying by some version of 1, meaning you're going to be multiplying your original expression by some new expression over itself in order to get rid of that radical expression in your denominator. So we need to figure out what radical expression would allow us to get rid of this radical 3, or the third root of 5y squared. Because it is a cube root, when we rationalize it, we're going to need to use a cube root. And what you need to do is you need to think of how many factors of each type of thing you have underneath your radical sign. So right now we have one factor of 5, and we have 2 factors of y, because we've got y squared. Because we're taking a cube root, we ultimately need 3 factors of each of those. So when we rationalize this, we're going to need to multiply by 5 squared, because that will give us 1, 2, 3 factors of 5. And then we're going to need to multiply by just 1y, because that will give us 2, 3 factors of y. Now, of course, like I said earlier, we're just multiplying by some odd-looking version of 1. So whatever we multiply our denominator by, we must also multiply our numerator by. So in order to rationalize our denominator, we must multiply by the cube root of 5 squared y over the cube root of 5 squared y. So let's go ahead and carry that out. Whenever you multiply two fractions together, of course you multiply the two numerators together and then the two denominators. So we're going to have the cube root of 7 times 5 squared times x times y. All that messy stuff will be in our numerator. And then in our denominator, we'll have the cube root of 5 times 5 squared times y squared times y. Of course, I'm running out of room again. Just give me a moment. Alright, so 7 times 5 squared is 7 times 25, so we've got the cube root of 175 xy, that'll be our numerator. In our denominator, we'll have the cube root of 5 times 5 squared is 5 cubed, and y squared times y is y cubed, which is exactly what we wanted. Don't believe 175 has any perfect square or perfect cube factors, so we're not going to be able to simplify. Oops, it's 175. We're not going to be able to simplify the numerator at all, so that's just going to stay the cube root of 175xy. And then, of course, because of the way we intentionally rationalize our denominator, because we have a cube root and we've got 5 cubed and y cubed, we can take the cube root of both of those, and our denominator will just end up being 5y. And there's the simplified version of our original expression.